Right now, almost every new car has some lower level of autonomy on it. But what many are holding their collective breath for are cars with what the EPA calls Level 4 and 5 autonomy. Today, our expert panel tells us just how far away we are from true autonomous vehicles.
In the auto industry, you need a partner that can develop the next game-changing technology and mass-produce it quickly. BorgWarner can. Our expertise drives future mobility trends with fast-to-market solutions for clean, efficient propulsion systems. We understand the challenges you face. We know what you need to get ahead. We take innovation from the drawing board to the road quickly, providing localized production around the world. BorgWarner, your partner in propulsion system solutions for a cleaner, more energy-efficient world.
And now, here's your host, John McElroy.
I want to thank you all for joining us on Autoline this week. Topic today, autonomous vehicles, one of the most exciting things to hit the automotive industry. And I've got three top-level people to talk about where we are and where it's going. First up, Dr. Ryan Eustace. He's the Vice President of Autonomous Driving with the Toyota Research Institute. Jada Tapley is the Vice President of Advanced Engineering with a company called Aptiv. We'll get into that in a little bit. It used to be called Delphi, or it's split, but like I said, we'll get into it. Also joining us is Sam Abulsamid with Navigant Research, and great to have the three of you here.
Thank you.
Great to be here as always.
Well, let me start out by saying this. We've got different automakers saying all kinds of different things about autonomous vehicles. Elon Musk at Tesla says we're going to have fully autonomous Level 5 vehicles by 2019. Some other automakers like Ford and BMW are talking in the 2021 time frame. Others say, nah, this is years away, decades away. Ryan, why don't I start with you? Where's this going? Where are we? What's happening? What do you think of what others have said?
Well, I think in terms of autonomy, you know, we have these different definitions in terms of Level 4, Level 5. It's interesting you mentioned this Level 5 idea, which is basically the car is able to drive anywhere, anytime, and any kind of weather condition, like a human today. I think that is many years off. The idea of like Level 4 autonomy, where the car might operate in some geo-fenced or kind of restricted area, I think it's actually closer than we think. It's right around the corner, really.
Jada, what do you think?
I think it's all about application. So if we think about the traditional kind of consumer model today, the OEs sell cars to end consumers like us. But if we think about Level 4, Level 5 automated, especially in the near term, the costs are going to be pretty high as the technology evolves. So it's perhaps more of an AMOD type application we're going to see around fleets, because those fleets, much higher utilization than a consumer, able to absorb those costs that perhaps a consumer can't. So that's why at Aptiv, we're really pushing in the smart cities, because that's where we're going to see a lot of this AMOD come into play.
Sam?
Yeah, you know, as Ryan and Jada said, you know, Level 4 is, you know, a car that's capable of driving itself, but under certain very specific conditions, and that's what we're going to see, where the conditions allow it, like in cities where the weather's good and the infrastructure is in place. That's what we're going to see in the next few years. I mean, we're already seeing pilots of it now. Delphi is doing some stuff in Singapore, in Ann Arbor, not far from here at the University of Michigan. They're starting to run some Level 4 low-speed shuttle services, and I mean that's obviously much more constrained than what most people think of as a autonomous car, but it's still capable of driving itself without human intervention, but within that limited scope. And then as the technology improves and gets more affordable, that scope will increase, and you know we'll eventually get to Level 5. And I agree also with Ryan that I think you know we're probably looking at late 2020s before we get to Level 5. And the cars that Tesla is building today, they'll probably never be Level 5, no matter what software you put in them.
Okay. As you said, the technology is developing. In fact, to me, it's rocketing forward. Ryan, I want to ask you this. In 2013, there was a Toyota executive who said, we're really not interested in autonomous cars. We're not going to build them. Now, you're the vice president of autonomous driving. What was some of the thinking that changed at the company?
Really, I think it was Akio Toyoda, who is, you know, an avid driver and lover of cars, right? And I think it was his realization of how do we enable mobility for those that are not able to access mobility that we take for granted today? So when you think about the blind or the elderly, basically how can we provide them smooth and easy transportation as well? And I think that was really a pivotal moment for him in terms of the role he saw that autonomy could play. And as you've seen, Toyota's now really going for this by creating the Toyota Research Institute and moving very rapidly in this space.
Yeah, Jada, same question. The company formerly known as Delphi now has spun off the high-tech part called Aptiv. But going back some years ago, what led Delphi to say, we've really got to develop this technology?
We've had a lot of visionary people, and if you go back just in our history, the first in-dash radio in the 30s, I mean, I can't even comprehend that, right? The first cruise control in the 50s. So we've always been kind of on the forefront of that technology and bringing that technology into automotive. And it's really no different here. We invested very heavily, and Automatica acquired them back in 2015 because we saw that this is where the industry is going. Did our first cross-country drive, got lots and lots of data. So it starts in the roots of all the active safety technology that we've had, and then recognizing where this is going to go, watching the industry and being leaders in that.
What should the industry be doing in this sense? So many companies, automakers are developing this technology. So many suppliers like Delphi are developing this technology. All kinds of startups jumping into it. Sam, how do you think this is going to shake out? It's the classic make or buy decision confronting an automaker. Do I make it in-house or do I buy it from these suppliers? Where do you think it's going to go?
A bit of both. You know, the traditional auto industry and its supplier base has enormous resources in terms of manufacturing capabilities and engineering resources, and its ability to design and manufacture products that operate within an enormous range of environmental conditions, from 40 below zero to 120 above, dealing with different kinds of weather, vibration, and those are things that the startups just don't have the expertise at this point to do. But the startup community has a lot of great ideas in terms of how to potentially solve some of the technical challenges, especially from a software perspective, and also from the electronics, you know, lowering the cost of things like LiDAR sensors, getting more powerful compute platforms. So the combination of those two, I think, is what it's really going to take to succeed. And that's why you're seeing companies like Delphi and Toyota and all the other traditional players investing in a lot of these startups and forming partnerships to bring all those pieces together.
You mentioned all the validation, and sometimes I think that point gets lost. And for the OEs, automotive grade is something we cannot take for granted.
Explain that, automotive grade, because not a lot of people are familiar with that term.
So it's the validation requirements, which is effectively testing requirements that are required in the automotive space, are a lot more stringent than those in the consumer space, from temperature ranges, so where the car has to be able to operate as much higher temperature extremes than in the consumer space. And we're all used to our phones resetting all the time, right? Or all of a sudden we get pushed a new update and we take it as normal. That's not normal in your car, and when something happens like that, it's a bad thing. So when it comes to taking all this technology that's in the consumer space, bringing it into the car, we have to make sure that we're putting it in the car in such a way that it's automotive grade. And the other piece that's often forgotten about, especially with autonomy, is functional safety. And it's something that you don't hear a lot about when you're talking to various people, but there's very stringent safety requirements associated with autonomous driving, and specifically level 4 and 5. And that's driving fundamental changes to how the car must be architected in order to achieve that. And while these new players in the space, very, very smart, highly capable, because they don't have that auto experience, that heritage there, they're seeing struggles around how do we package this in a vehicle, how do we make it automotive grade, how do we make it functionally safe.
And just to add to that, you know, traditionally with active safety systems and driver assist systems that we have today and we've had for the last several decades, when those things fail, the approach has been to turn on a warning lamp and the driver takes responsibility. You know, if your ABS fails or your lane keeping system stops working because the sensor can't see the road, you know, the driver is the backup. We're the redundant system. But if you've got a vehicle that's going to be capable of at some point in time being able to operate without a human in the vehicle, then there has to be redundancy for a lot of those systems, the compute platform, a lot of the actuation, some of the sensing, and because it can't rely on a human to take over. It has to be able to take over itself.
Yeah, and that's actually, I mean, that mindset, when you talk about level 4, we have to remember that with level 4, the human is always a passenger.
Yep.
And so the person that is in the vehicle may not be capable of the driving task at all, right? It might be the blind or the elderly. It might be my 5-year-old son being shuttled to school in this vehicle. And so it has to have the autonomy and the ability to get from point A to point B and to handle all of the irregular things that happen when we drive on real roads.
So Ryan, what's the advantage of Toyota developing this technology in-house and not going to somebody on the outside?
So I think Toyota is one of those companies that has the scale to actually try to take on a lot of this problem internally. And importantly, as Jada was saying, that when we want to bring this to market, when we look at the scale of Toyota of wanting to release this technology on the order of 10 million vehicles per year that we build, how do we ensure and guarantee the reliability of these systems? So we are investing very heavily in terms of some of our simulation capability as one of the ways that we're able to think about how we're able to make improvements to our autonomy software and then be able to run it in simulation to basically validate that and then to think about how that can get pushed to the vehicles, and then it might be able to run in maybe a ghost mode in the car, get some real world validation, and then enable it.
Jada, and yet Aptiv is developing technology, or I should say autonomy in a box. And you guys have got this like productionized. It's not some laboratory kind of experiment.
Right.
Why shouldn't a company like Toyota or other automakers just say, why should we develop it? We'll just go buy it from Aptiv.
Well, we're more than happy to work with Ryan and his team to do that. But our experience with automakers all around the world is they tend to have varied approaches. There's some that want to do it all themselves, and there's some that want you to do everything. And what we do is we say, okay, if you want to do it all yourself, we'll be your systems integrator. We'll work with the other suppliers, because it's not just you, and we'll pull everything together for you because we've got that capability. At the same time, if you want us to do it all, we've got a turnkey solution, leveraging the best of the best that we can drop in your car. And if you want a mixture somewhere in between, we can do that too. But one very interesting thing that we've been talking a lot about, I know we've talked with Sam about it, but that also doesn't get a lot of discussion time, is what I like to call the unsung hero in the car. And it's something we take for granted, but if it doesn't work, nothing else works. And that is all about the architecture. And when we start seeing shifts towards level 4, level 5 automated, and the massive amount of growth in content and software in the car, that's driving changes to the amount of horsepower that we need in the computing platforms. And that's driving a fundamental shift in how the car itself is architected. What does the data network look like? What does the power distribution network look like? And so that's something we're engaging with the OEs, with our partners, to have those conversations to say, okay, we need to rethink the architecture. We have to make it smarter. We have to incorporate all this new technology that's coming in, and we have to make it safe. And so that's one of the things that we are really focused on, is getting the foundation right so we can build on that.
And when you say architecture, you're not talking about the physical steel and plastic.
It's
you're
really
talking
well, that's an important part of it too.
It's very important, but you're talking more the electronic architecture of the car, right?
It's basically, it boils down to three things. And three things in the design. The first is the software framework. The second is the hardware, so think your sensor package, your compute platforms. And then the last is how the data and power is distributed throughout the vehicle. But it's not just isolated to the vehicle. As we start thinking about level 4, level 5 automated and AMOD solutions, smart cities, the vehicle is connected in ways we've never imagined to the outside world. So when we talk architecture, we're talking those three items: the software, the hardware, sensor package and compute, and data and power distribution in the car, but then that connection to the outside world as well.
So is that your message to the guys at Toyota who have been traditionally designing cars? Hey guys, throw it all out the window. We're starting all new.
Well, and I think that's actually why Toyota created the Toyota Research Institute, to really take on this massive challenge of thinking about how we architect these systems, how we really transform Toyota into being a world-class developer of autonomy software, to marry it with their expertise in the actual manufacturing of these things at volume and with high reliability. And so, yeah, very much that is our mission within TRI.
And as we look at a shift away from personally owned vehicles towards mobility as a service, especially in urban areas, one of the goals of that is to maximize the utilization of the vehicles. I mean, today, vehicles sit idle 95% of the time. Parked, we drive them for maybe an hour, hour and a half a day most of the time, and we want to utilize those vehicles so that we're taking up less space on the road, less resources, and in order to get that high utilization, we need to rethink how we build cars, because those cars are going to have a different kind of life cycle. Instead of lasting 15, 20, 30 years, they're going to, at least some major components of it are only going to last a few years, and then you're going to have to upgrade, replace, recycle, and so, and then we also want to provide flexibility in those vehicles. At some points during the day when there's demand, you want to move people. At other times during the day, you want to repurpose those vehicles quickly to maybe use cargo delivery, package delivery, pizza delivery, as Ford's been testing out with Domino's with one of their vehicles. So we're going to see different kinds of vehicles that are designed specifically for autonomous. And there's a bunch of startups in the Valley that are doing some of this stuff, guys like Next Transportation and Navia and Local Motors. So it's going, the nature of vehicles is going to evolve with services and automation.
In fact, sorry, go ahead.
Well, I was actually going to say that, in the space of trying to rush toward automation and think about how we can enable the car to drive itself and the human as a passenger, at Toyota we also view that there's an amazing kind of opportunity of how we can use that same backbone of technology to make you a better driver. So with our Guardian application, we're actually working on how we can try to build an uncrashable Toyota by thinking about this backbone of how we have a sensor-rich car, computation-rich car, where the human's actually driving, but the car is always monitoring the situation around you and is ready to intervene to help prevent a crash from happening.
So it's the electronic guardiing angel sort of concept,
exactly.
right?
Well, and actually, I mean, Toyota's been a pioneer, I think, in terms of coaching drivers in the vehicle. Going back to the beginning of the Prius. In the Prius, they've always had a lot of extra information that we didn't have in traditional cars to help coach drivers to drive more efficiently. Well, now with Guardian, they're looking at going further than that, beyond just the efficiency, but overall safety and how we drive our vehicles, and I think that's a good thing.
There's a number of studies out there building on what you just talked about, Sam, that say car sales are going to plummet in the future because we will be doing more sharing. We're not going to need as many vehicles. How do you guys see it? Jada?
I think perhaps the traditional model of car sales might change, right? We're talking about a fundamental shift in the auto industry. It's almost like we're switching from the feature phone to the very first smartphone. And many times when people got that first iPhone, it was almost overwhelming. What do I do? You couldn't imagine doing anything other than talking on the phone, and then all of a sudden you can text and you have pictures and now you have apps and you have all these things, and now we can't live without it. And I think we're at that cusp. We're right on the cusp of the car transforming from this transportation device to really a mobility device. And that's going to fundamentally change how we think about the business models too. Perhaps it's not just a business to consumer type of thing. Maybe it's a lot more fleets. So it's all about, we have to rethink how we think about things. It's not just the traditional way, it's a brand new way, and we get to kind of plow that road. We get to pave new ground here.
Ryan, are we going down the road to the point where Toyota's customers are fleets and not retail customers?
I think that's a very plausible type of scenario. I think one of the first applications of truly an L4-like system will probably not be in a personally owned vehicle, but it'll be in a mobility as a service type of application, because it's more than just the car. It's part of this ecosystem where in the mobility as a service, because utilization is high, we can afford to put better sensors and equipment on the vehicle. It can be part of a network where we think that because where the pickup and the drop-off is, there's a lot of constraints that we can put on this that make the realization of deploying an L4 system with mobility as a service first, I think, is the natural choice.
And then we learn from that, right? Yes. I mean, even when you're talking about Guardian and being able to help teach your drivers, you're teaching the car at the same time. And that's making, when we get to these L5 systems, when we get to the point where we're deploying to the consumers, they are that much smarter for all the learning that they've done through the mobility as a service, through the Guardian, through all of those things, and they're ready for that mass deployment to the average consumer.
And in the long term, there probably will be, or almost certainly will be, a decline in total vehicle sales, whether it's to consumers or even to fleets. But at the same time that that's happening, that's going to be offset in part by the fact that we do have a growing population, and more of that population is living in cities every year. And at the same time, through automation, we're enabling mobility for people who today can't drive. So that means there's going to be more increasing demand for transportation, and so that's going to offset some of the fact that we're selling fewer vehicles to consumers, but we're using them in different ways, and because they also have that different life cycle I talked about, you're going to need to replace and replenish some parts of that on a much more rapid basis than we do today.
Sure, I think we're going to see many more cars on the road, but fewer cars parked. In fact, maybe no cars parked at some point.
Well, I mean, there will always be some that are parked somewhere, either being charged or refueled or serviced. But yeah, in general, the way we think of cars being parked today will largely go away. And that's actually a good thing for cities too, because cities today have huge swaths of land within the urban cores that are dedicated to nothing more than storing idle cars. And that's, in places like San Francisco where, land values are so high, if you can take some of the, they've got 440-some thousand parking spaces in San Francisco. If you can take some of that land and repurpose it for other uses, residential, commercial, there's a lot of new business opportunities there.
So if the industry sells fewer cars, it would seem to be a negative for the industry. But Ryan, one of the things that's been talked about is monetizing the data that these cars are going to generate. The vehicles themselves and the people in these cars, which when they're fully autonomous can do whatever they want, generating yet more data. Is that something that you're looking at?
Yeah, and this is a whole new space, I think, to really think about with these vehicles. When it comes to monetizing data, one good example I can give is that if you look at some of the maps that are being generated today, they're generated with basically special survey vehicles that will go out and create a map. And it becomes very hard, as soon as you make a map, it becomes out of date. And one of the scalable ways that we can actually build and maintain these maps is actually to think about these vehicles become data probes themselves.
Yes, they do.
And by connectivity back to the cloud, we're able to automatically refresh and pull back this data at all times.
We're all cartographers.
Yeah, exactly. So yeah, our cars become cartographers.
Right.
And so that becomes one actual concrete example of how we can think about through the Toyota fleet, we can actually monetize that in terms of how we are able to produce data for maps.
And even in smart city applications, along the same line, we think of the cars as having sensors, but we're at the point where the car is a sensor. And especially when you have all these fleets operating in these smart cities, they can now get all that data. And so think traffic. Traffic congestion, as I'm learning here as I move to Detroit, is a real issue. Imagine if the cars could send the traffic information to the cities can then adjust traffic lights to be able to maintain the flow of traffic, perhaps make changes based on emergency vehicles. Not only does it become safer, but emissions go down, you have a better quality of life for your residents, and it's a new monetization opportunity all at the same time.
Yeah.
Another possibility is, today, we go out and do some shopping, run some errands. We may make 3 or 4 or 5 stops, and between each stop, we throw our stuff in the car and then go on to the next place. Well, if you're jumping around from one vehicle to another using a mobility service, you're not going to want to haul that stuff around with you all day, and you're not going to want to leave it in the car. But what you could do is you go and you do your shopping, and the stuff gets packaged up for you, and then at the end of the day, one car goes around and stops at those 4 or 5 places again. Somebody comes and loads the stuff in there and then drops it off at your home, and so you don't have to worry about dragging everything around all day.
Who owns the data, though? Is it going to be Toyota? Is it going to be Aptiv making the technology for it? What about us in the car? I want my piece of the action.
Yeah, well, I think it's very important, right, in terms of respecting consumer privacy. And so I think any kind of data model that we have is is an opt-in policy where the consumer is aware of that choice. And I think we have to think about what's the benefit that they get back because giving us access to data to incentivize them, right, we want to be able to return something in service for that.
Yeah.
Here's the thing that I find really exciting, and we talked before about some of these visionaries back in the 80s that saw this future that we're now working on. The fact that we have so much data in the car, the fact that we have an architecture that allows us to do the high-speed edge processing that we need to and get it out to the cloud, opens so many new doors for us that we couldn't have even imagined before. And it's so exciting just to think of all the new opportunities that are out there. And we may choose to walk through some of those doors, we may choose not to, but the fact that there are doors there, it really illustrates the transformation that the industry is going through.
And with all this data flying around all over the place, one thing that the industry is now really starting to pay much more attention to is the security of that data.
Yep.
Making sure that both individual data is protected, but also that the data relevant to how the vehicles themselves are controlled is protected, because we definitely don't want to get into a scenario where somebody might be able to penetrate the system and be able to take control of an entire fleet of autonomous vehicles.
In fact, numerous studies show that the public is wary of autonomous cars, and Ryan, their biggest concern of all is just what Sam mentioned, somebody hacking in and taking control. Can you guys be fairly certain you can make a hack-proof car?
It's something we put a lot of effort and investment into in terms of really taking this very seriously. I think a vehicle is one of those challenging things because it's something that actually lives in the wild, and people have unfettered access to that. And so, but yeah, Toyota has put a lot of effort basically in terms of trying to think about the cybersecurity aspects of this to make this platform very secure.
And that's one of the things that we've incorporated into our architecture is the more access points you have into the vehicle, the more opportunities there are for a hacking attempt. So incorporating that into the architecture, creating that as a fundamental guiding principle of how we design it, we are getting closer and closer to that point where we can say we have a hack-proof car.
And so that's one of the areas where the startup community is really playing a big part with the industry as well as helping with security.
So that gets back to your discussion on architecture. It also is related to cybersecurity.
Absolutely. When we talk about getting to level 4, level 5, and we talk about all these new changes in the auto space, it starts with the architecture. If we don't answer that, we don't solve that problem, we're going to struggle to get there.
I'll bet you guys do solve that, because I've been so impressed the way the industry's been moving. Unfortunately, we're going to have to wrap up this discussion. For another day, though, I'd love to have you guys come back. So Dr. Ryan Eustace from Toyota, Jada Tapley from Aptiv, Sam Abulsamid from Navigant Research, thanks for coming on the show today.
Thank you.
Thank you.
And as always have to thank all of you for having tuned in.
In the auto industry, you need a partner that can develop the next game-changing technology and mass-produce it quickly. BorgWarner can. Our expertise drives future mobility trends with fast-to-market solutions for clean, efficient propulsion systems. We understand the challenges you face. We know what you need to get ahead. We take innovation from the drawing board to the road quickly, providing localized production around the world. BorgWarner, your partner in propulsion system solutions for a cleaner, more energy-efficient world.